So this is the 2014 Leaving Cert Higher Level Paper 1, and we're looking at question number 2. Let Z1 be equal to 1 minus 2i, where I squared is equal to negative 1. Part A says the complex number Z1 is a root of the equation 2z cubed minus 7z squared plus 16z minus 15 equals 0. Find the other two roots of the equation. So this is a cubic equation. Z is the unknown, so we're looking for z. Now we know one of the solutions for z, which is 1 minus 2i, and that's complex. So solutions for equations like this, if you have a complex solution, another solution would be the conjugate of that. So another solution would be the complex conjugate of 1 minus 2i, which is 1 plus 2i. So that's one solution. The other solution was given, which is 1 minus 2i. That's the one given in the question. So just like with quadratic equations, if you know a solution, from the solution you can work backwards and get a factor of the quadratic expression on the left. So if z equals 1 plus 2i is a solution, well then z minus all of this, in other words bringing this over to the other side, which would be minus 1 minus 2i, that's going to be a factor. Similarly, with 1 minus 2i, if we bring the 1 over, it becomes minus 1. And if we bring the minus 2i over, it becomes plus 2i. So that's another factor. So if we know two factors, we can multiply these together and compare it to the cubic here to find the third factor that we're looking for. And from that factor we can find the root. So firstly I'm going to multiply these two factors together. So I've got z minus 1 minus 2i multiplied by z minus 1 plus 2i. Okay, so z by z gives me z squared. Then I have z times minus 1, which is minus z, minus 1z. And finally z times 2i is plus 2zi. Next I've got minus 1 times z is minus z. Minus 1 times minus 1 is plus 1. And minus 1 times plus 2i is minus 2i. Finally then, I've got the third term here. Minus 2i times z is minus 2zi. Minus 2i times minus 1 is plus 2i. And minus 2i times plus 2i is minus 4i squared. So lots of terms here when you multiply out, but some of these are cancelling. You've got plus 2zi here and minus 2zi there. I'm just going to color code this to make it clear. They cancel. You've also got minus 2i plus 2i, and they cancel as well to give 0. So you're left with z squared term minus z and another minus z gives you minus 2z. And then finally you've got plus 1 and minus 4i squared. Now because I squared is negative 1, minus 4 times negative 1 is plus 4. So this becomes plus 4. And plus 4 plus 1 is plus 5. So this is what we're left with when we multiply those two factors. So to find the third factor, we just need to, well, there's a few things you could do here. You could divide the left-hand side here by this, using long division algebra, or you can use the grid method. So I'm going to use the grid method. It's a little bit easier. So I know if I divide a cubic by a quadratic, I'm going to get something linear. So I'm going to set up a grid like so. It's going to be a 3 by 2 grid. I'm going to put my quadratic factor up here, z squared minus 2z plus 5, and I'm looking for this factor here, and I can put the 2z cubed, I can put that in here, I can put the minus 15 in here at the end, and I can work backwards from here. So what do I need to multiply minus 15 by to get positive 5? Well, that's minus 3. And here I can just say, what do I need to times z squared by to get 2z cubed? Well, that would be 2z. So I don't even need to work out the rest of the grid here. You could if you like, but I know now that my third factor is 2z minus 3. So 2z minus 3, these two terms here, that's a factor. So if I let that equal to 0 and solve for z, I'm going to get the root that I'm looking for, the third root. So I'm going to bring the minus 3 over the other side, becomes positive. So 2z equals 3. Divide both sides by 2. Z equals 3 over 2. So z equals 3 over 2 is one answer, and z equals 1 plus 2i is the other answer. They're the other two roots that I was looking for, so I'll just make that clear. The two roots are here and there. Okay. Part B1 says, let W be equal to Z1 times the conjugate of Z1, or Z1 bar, where Z1 bar is the conjugate of Z1. Plot Z1, the conjugate of Z1, and W on the Argand diagram and label each point. Okay, so Z1, which was given, was 1 minus 2i. So we go over to 1, then down to minus 2i, and plot, that's going to be Z1. Z1 bar is the conjugate, which is this one here, that's 1 minus 2i. Sorry, that's 1 plus 2i. So we go over to 1 and up to plus 2i, so that's going to be Z1 bar. And then finally W, and they tell us that W is Z1 times Z1 bar, so W is equal to Z1, which is 1 minus 2i, multiplied by its conjugate, 1 plus 2i. So I'm going to work this out. 1 times 1 is 1, minus 2i by 1 is minus 2i, 1 by plus 2i is plus 2i, and minus 2i by plus 2i is minus 4i squared. So tidying this up, the minus 2i and the plus 2i combine to give 0, and I've got 1. Minus 4 by I squared is minus 4 by I squared, but I squared is minus 1. So that's 1. Minus 4 by minus 1 is plus 4. So 1 plus 4 gives us 5. So W is equal to 5. So if I'm plotting 5, I just go over to 5 on the real, and that's W. So I've plotted them and I've labelled each point. Part 2 then says, find the measure of the acute angle Z bar 1 WZ1 formed by joining Z bar 1 to W to Z1 on the diagram above. Give your answer correct to the nearest degree. Okay, so the angle I'm going to be looking for then is, it says to join Z bar 1, which is this, to W, and from W then to Z1. And that I'm looking for that acute angle. So the angle I'm looking for is this angle here. Okay, so if I want to find this angle, well, what I can do is, if I imagine this right angle triangle above, and I look for this angle here, I'm going to call this angle here X. If I'm looking for this angle X, because this right angle triangle up here above the real axis, that's a right angle triangle, and this angle X will be half the total angle that I'm looking for. So once I find X, I'm going to double it. Well, this angle here, X, I know the opposite side here is 2 high, and I know the adjacent side of the triangle goes from 1 to 5, which is 4 units. So I can say that the tan of X is the opposite, which is 2, over the adjacent, which is 4. So if the tan of the angle X is 2 over 4, well then the angle X is the inverse tan of 2 over 4. And the inverse tan of 2 over 4, do this in our calculator. That gives us 26.565 and so on degrees. Okay, so that's X, but the angle I'm looking for is twice that. So twice X is equal to 53.130, and on it goes, degrees. But they want the answer correct to the nearest degree. So to the nearest degree, I'm going to look to the digit after the decimal. This 1 doesn't affect the 3 in front. So the angle then is just 53 degrees. That's the acute angle that we're looking for. And the end of B2 and the end of question number 2.